Ah, I see you've come back. That's terrific because the rational zero test is really helpful. You're going to like it. It says that all possible rational zeros can be found by taking all the factors of the last term over all the factors of the leading coefficient. Okay, now let's untangle this a little bit. First of all, the term possible. Okay, many of what you come with are not going to be solutions. However, all of the rational zeros are guaranteed to be on this list. And let's talk about the term rational. You guys should already know what that means. Rational solutions do not include radicals or imaginary solutions. A rational term is any number that can be expressed as a fraction or a whole number. All right, so, and these are the numbers that we're interested in, because if we're trying to find zeros, we'd like to find ones that actually cross the x-axis, not ones that are in the imaginary realm. So, like I said, it's going to give you a whole list of possibilities. Not all of them are going to be solutions, but that's going to be where you start. It's going to give you your rational list. So if we have, okay, now we have to kind of talk about it in formal terms. If you have the expression f of x and it equals this thing, and by the way, this little, where did it go? That little, okay, it just vanished. Ah, there we go, okay. This is basically saying, this is a number, a coefficient, and this is x to some power. So for all you know, it could be 10x to the 6th plus, and then if this is our first term n, a sub n, our next term is a sub n minus 1. Okay, all it is a number. So this is a formal way of saying any stinking polynomial that you come up with. Okay, so maybe you want to write that in your notes. Any stinking polynomial that you come up with. You can find the rational zeros by doing the following. Taking all the factors of the last term, a sub 0, over all the factors of the first term, a sub n. Like thus. Okay, now hopefully you'll be really lucky if this first term here is a 1, because that drastically reduces the number of possibilities that there are. And you'll see why in just a second. So, let's see. Let's put this in action, huh? Let's say we have x to the 4th minus x to the 3rd plus x squared minus 3x minus 6. I have conveniently notated the last term and the first term. The last term is negative 6, and the first term, conveniently, is 1. So to find our possible, just a list of possibilities, we take all the factors of 6 over all the factors of 1, and I left them in fractional form, but you can see that 1 over 1 is 1, 2 over 1 is 2, and so on. All right, and you need to understand also the plus or minus, meaning it could be a positive root or a negative root. All right, so this is where we start, okay? We know that if we have a 4th degree polynomial, we're going to have 4 linear factors. Okay, we don't know what they are, but this is where we're going to start. We would take this polynomial and we would start off by synthetically dividing by 1, by 2, by 3, by 6. And it'll break it down further, and then we can possibly factor it down the road. Okay, so actually finding the zeros becomes a bit of trial and error. And there's no other way to put it. It's trial and error. You try one, works. You try another, doesn't work. So this is how it would look. Okay, I'm first going to divide by 1. All right. And as you can see, it does not come out evenly. There I tried and failed. You're going to do a lot of trying. You're going to do a lot of failing. In the end, hopefully you'll learn better ways of trying and fewer ways of failing. It just takes practice. All right, let's try -1. Boom. There we got our first factor, -1. All right. Once you factored out 1, 0, use the quotient to continue the process. It will make things much easier. Instead of going back to this set of numbers and synthetically dividing, we already know that it breaks down to this, so just divide this one. There's fewer terms. It's going to be easier. All right, and like I wrote down here, I usually stack them and continue dividing. So let's try another number. Let's try 2's. Okay, 2. Does 2 work? Come on, 2. Show me a 2. Oh yeah, 2 works. So now I know that I'm going to have factors of x plus 1, x minus 2. And this last row that I have here, well, I know that that's just x squared plus 3, right? Right? Now the quotient is something I can easily factor. X squared plus 3 ends up being x plus square root of 3, x minus square root of 3. All right, I've got all my zeros, and they are -1, 2, and plus or minus square root of 3. Now, I want you to note that the last 2 zeros that I got, which were plus or minus the square root of 3, are irrational. Okay, I would not have gotten them but through factoring. Factoring those two guys. All right, so we start with our rationals, and it's going to hopefully break it down into something that we can factor ourselves. And a lot of times it's going to end up being irrational or even complex. Let's continue. All right, we got 2x cubed plus 3x squared minus 8x plus 3. All the factors of 3 over all the factors of 2. All right, the factors of 2 are 1 and 2, so that's going to make things a little different here. Okay, the factors of 3 are just 1 and 3. But since the factors of 2 are 1 and 2, I can have 1 over 1, or I could have 1 over 2. Then I could have 3 over 1, or 3 over 2. And all of them could be positive or negative. So trial and error. Let's try -1. No. All right. Let's try +1. Excellent, I got one. I like to start with the simplest numbers possible first because, you know, none of us like to do a lot of work, do we? So let's try simple numbers first. Okay, so now I know 1 is a 0, and furthermore, that 2, 5, and 3 should be factorable if I wanted to. But apparently I didn't want to. I decided I was going to divide by a -3 this time. And lo and behold, that also works. And what's that last quotient that I have there? 2x minus 1, I know that gives me an x, or 0 of 1/2. So this time all three of the zeros for this function were rational numbers. That means that that's where they cross the x-axis. That's really going to help us figure out how to graph these beasts. Yes, the zeros are -3, 1, and 1/2. Okay, swell. What's next? One more. All right, I'm going to have you guys try this one. The one that's supposed to be appearing right now. See? Come on. There we go. All right, you guys try. Ooh, 34. Well, there's not that many factors of 34. Plus you got a 1 in front of the x cubed. All right, go ahead, do it. Solve it. Okay, our possible zeros are going to be the factors of 34 or the factors of 1, which gives us 1, 2, 17, 34. I'm going to start with the easy ones, -1. What does it get me? All right, let's try +1. Another bad one. All right, let's try -2. Another bad one. See, it's trial and error. Okay, it's hit or miss. Try another. +2. I'll stop singing now. Ding, 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 ding. We have a winner. All right, so there we go. And looks to me like the rest of it is factorable. Or is it? Nope, because they have to be the same sign. And it's not a 15, it's a 17. I'm an idiot. Anyways, how do we know that that's the only rational zero? Well, at this point right here, you'd have to use the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. Well, you can see right here I got 4 times 17. That's a lot bigger than 4. So I'm going to get a negative under the radical, which means it is imaginary. That's how I know that 2 is my only rational zero. Yep, see, there I wrote it. Now it's official. Okay, pay attention to what they ask you for. Problem may simply ask you to list all of the possible rational solutions. All right? That's just the list. That doesn't mean you have to actually go through and find them. It just wants the list of all the possibilities. I'd hate to see you guys scrambling around to find the zeros and spending a half hour on a problem that ultimately would only take 40 seconds. All right, that's it for this one. The next video is about irreducibility. Adios.